A hydrogen fuel cell uses hydrogen and oxygen to generate electrical energy in an electrochemical reaction. A hydrogen molecule is combined with an oxygen molecule to produce water, electricity, and heat. A fuel cell uses hydrogen gas to generate electricity. It splits hydrogen molecules into negatively charged electrons and positively charged protons, which are represented by the symbol H+ in the image. The protons can pass through the membrane in the middle of the cell. The electrons are forced to take a different route, creating an electrical current. As they reach the side of the cell, the protons and electrons combine with oxygen from the air to form water molecules. Hydrogen fuel cells generate energy sustainably with zero emissions. Here we can see a stretched smart wire connected to an electrical circuit with an open switch. By flipping the switch, we are completing the circuit. When an electrical current passes through a smart wire, it heats up, and when a smart wire is heated, it contracts. When the electric current is switched off, the smart wire stays the same length. If a force is now added to the smart wire, it will stretch back to the original position. On heating, the wire will contract again, and the cycle of contraction and expansion continues. We can use a simple model to explain this behavior. A smart wire is made of an alloy of nickel and titanium in a 1:1 ratio. The alloy can exist in 3 different forms, each with a different arrangement of the nickel and titanium atoms. Initially, the smart wire is in the deformed martensite form. When it's heated, the atoms rearrange to the austenite form, and this leads to a contraction in length. This is the remembered form of the alloy. When the austenite cools down, the alloy changes to the twinned martensite form. The size and shape on a microscopic scale are the same as in the austenite form, and so there is no observable change in length. If a force is now applied to the wire, it stretches as it changes from the twinned martensite to the deformed martensite form. Polyethene is made by the addition polymerization of ethene. Each ethene monomer has a double bond. During the reaction, the double bonds open up and the monomers join together to form a long molecule called a polymer. In this case, polyethene has been formed. The brackets and the bonds at the end indicate that only a small portion of the molecule is being shown here. In fact, polymers are made up of millions of repeating units. The repeating unit, in this case C2H4, is used in the formula of a polymer. The idea of a repeating unit makes it easier to represent reactions to form polymers and the structure of the polymer itself. The equation for the reaction is shown here. N is a large number. Now let's take a look at another example. To find the monomer used to make this polymer, first you need to identify the repeating unit. Then replace the horizontal carbon-carbon bond with a double bond and remove the unnecessary side bonds to find the monomer. The monomer is propene. The polymer is polypropene.